In this session, I will explain you people about the design of a control unit. Now, if you want to design the control unit, let us understand and just have a recap of the instruction cycle. Just brush through the instruction cycle, what we have done and what we have learned in the instruction cycle, because it is pretty much important to understand this before we start the control unit. Before we start the control unit, I'm just brushing you up. What are the different phases we went through in executing an instruction? You know that I'm not discussing about this. You know about the different fields of an instruction. Now, these are program counter, address register, instruction register, data register, and accumulator. Now let us understand quickly, what are the different phases that this instruction going through. If you want to fetch an instruction from the main memory, first of all, PC needed to be transferred to the address register. The first operation that is needed to be performed is the program counter should be transferred to the address register. Then memory of the address register should be transferred to the instruction register, right? So after current instruction, after the next instruction becomes a current instruction, I need to update the program counter to the next instruction. That is, here the program counter should be 24, because the program counter always points to the address of the next instruction. Program counter doesn't hold the address of the current instruction. Okay, now program counter should be updated to 24. Here it is not shown, but you assume that the moment the current next instruction becomes a current instruction, program counter will hold the address of the next instruction, that is 24. Program counter should be incremented. Then we need to fetch the operand. Once the operand is fetched, finally the operation is going to be performed in between whatever the accumulator or whatever. Now try to understand here, whatever it is being happened, there is a specific order, right? That is, the first thing that is needed to be done during the instruction cycle is transferring the program counter to the address register. Then memory of address register to the instruction register, thereby fetching the operand, and all these operations are being performed in a specific order, right? Who is going to specify this order? Let us understand. Okay, now let us understand this instruction cycle. Of course, if you want to execute an instruction, this instruction should be fetched. This instruction must be decoded. And, if this is an effective address, if this instruction, if the operand is available in a different addressing mode, that is indirect addressing mode, the effective address should be calculated. And finally, instruction should be executed, right? So here there is a specific order. As we have seen, first instruction must be fetched. After fetching the instruction, we should decode. Decoding meaning there is an opcode, right? Opcodes are several combinations of opcodes are available, right? From 000 to 111. We have memory reference instructions, register reference instructions, and IO instructions. To perform an operation, first of all, we need to decode the opcode. Okay, then once after we decode the opcode, we will be able to know what operation is going to be performed by the execution of this instruction. So that goes under the decode phase. Then we need to collect the operands somehow or the other. We have seen in the previous slide how we fetch the operands from the main memory. And finally, the instruction will be executed. After these three phases are finished, the final phase of the instruction is instruction will be executed. That's it. Okay. Based on the opcode that is decoded, the instruction will be executed within the ALU. That is, one specific operation is going to be performed within the ALU. Okay. Once after the instruction is finished, then again fetch the instruction, decode the instruction, execute the instruction. Fetch, decode, execute. This is the regular process of the CPU. That is because CPU will always be in the instruction cycle. That is fetch, decode, execute. Once after one instruction is finished, again next instruction will be fetched, decoded, and executed. For every instruction has to be fetched from the main memory, and it has to be decoded, and it has to be executed. The only task of the CPU all the time is being in the instruction cycle forever, unless there is an exception happen. Okay, exceptions, there are some exceptional cases. The CPU will always be in fetch, decode, execution. Okay, now if you want to go through this fetch, decode, execution, there will be a specific order. Who is going to define the order? Simple. The system will have a clock. The system is going to have a clock. The computer system is provided with something called a clock. Okay. What is a clock? This clock is going to define the clock pulses. Okay. This clock is going to give you the clock pulses. That is from T0 to, let us say, Tn. Tn. Now, during every clock pulse, there has to be a specific operation performed. Every clock pulse is associated to some specific operation within the system. Let us try understanding what are these clock pulses and which operation is going to be performed at each and every clock pulse. Okay. And before I tell you that, I need to explain you that now I'm using a clock in the system which counts a maximum of 16 clock pulses. Let us understand. My computer system is going to count from 0 to 15. Okay, that means that for executing an instruction, I'm giving a maximum of 16 clock pulses, during which the instruction should be fetched, the instruction should be decoded, and the instruction should be executed. T0, it will start from T0 and it will end with T15. Okay, from T0 to T15, all these operations are fetch, decode, execution should be performed. At the end of the T15, we will again reset the clock back to T0. T0, T1, T2, T3 till T15. So every instruction will be executed within this 15 clock pulses. That means that the maximum number of clock pulses that are provided to every instruction for execution, that is fetching, decoding, and executing, every instruction can utilize a maximum of 15 clock pulses. Once the instruction is finished, again the clock will be reset. Let us understand what are the operations that are going to be performed by this T0, T1, T2, T3, T4, or whatever. Okay. Now, what is T0? T0 is a clock pulse 1. T stands for time, time pulse 1 or clock pulse 1. Now let us say, in T0, the thing that is going to be performed is program counter to address register. You have already seen that the first operation that is going to be performed in order to fetch the instruction from the main memory is program counter value will get transferred to address register, right? Program counter value will get transferred to address register, right? You can see this. I'm going to, yeah. In T0, program counter will get transferred to the address register. Okay. In T1, you have already witnessed that memory of the address register will get transferred to the instruction register. In T0, program counter is being transferred to the address register. The very next thing is memory of the address register will get transferred to the instruction register, right? Okay. Now in T1, memory of the address register, which is an instruction, will get transferred to the instruction register, right? Now let us see. In the very clock pulse, PC, the program counter should also be updated to the next instruction, because The moment next instruction becomes a current instruction, program counter will get updated to the address part of the next instruction. Program counter will always store the address part of the next instruction. Okay, so that means the moment the current instruction, the instruction is available in the instruction register, the instruction becomes the current instruction. So the program counter will not hold the current instruction's address, rather it will be updated within the same clock pulse. Okay, and then after T0 and T1, the instruction is available in the instruction register. That means that the instruction has been fetched into the instruction register. That means that instruction fetch phase is finished. So we are done with fetch phase. Fetch is over. Fetch is finished. Fetch is over. Okay, so that is T0, T1 are provided for the fetch operation, the fetch cycle of an instruction. After fetch, what must be done? Decoding must be done. Okay, so now in order to decode the instruction, rather than explaining you people about how to decode the instruction, I will take the help of a control unit, and then we will understand how the decode of an instruction is going to happen. Okay, that we will see in the next slide.